Hi guys. So today we're going to look at our second conic section, which is an ellipse. So an ellipse is basically an oval shape, okay? It looks like an oval, something like this or something like this. So what an ellipse technically is the set of all points where the sum of the distances from any point on the ellipse to two fixed points, those two fixed points are called foci. So if the sum between those distances stays the same, then you have an ellipse. Foci is the plural of focus. So one focus, two foci. So an ellipse is going to have two focuses, which are just called foci. So there are a few links in Schoology to kind of help you see this a little bit more visually about what's actually happening here. But that's what an ellipse technically is. So just like with parabolas, these can be both horizontal and vertical. And depending on how it's written and what these values are is which way it's going to go. So these equations, if you look, they look very similar. There's really only one difference. If you look at the horizontal one, there's an a squared below the x. And if you look at the vertical one, there's a b squared below the x. So the a and the b change. The reason the a and the b change is between those two numbers, the a has to be the bigger number. The a has to be the bigger number. So if the bigger number is below the x, well, then this is going to be horizontal. If the bigger number is below the y, then it's going to be vertical. So that's kind of the difference between these two. So in this equation, HK is the center. And again, that's consistent. HK was the center of the circle. HK was the vertex of the parabola. HK is going to be the center next class as well. A needs to be the bigger number. The reason that a is the bigger number is because we're going to use this equation in order to find the foci. And if the b was bigger, you'd end up with a negative, which we don't want. All right, so again, if the bigger number is under the x, then the ellipse is horizontal. Let me just say this. I'll say the ellipse is wider. Okay, it's wider than it is tall. The major axis is horizontal. So on an ellipse, what you're going to have, and again, there's some visual things that are linked on Schoology for you to play around with. You're going to have a center. And then you're going to have kind of these two vertices here. If you were to draw a line through those vertices in the center, that would be the major axis. So that major axis is horizontal when the bigger number is under the x. If the bigger number is under the y, that major axis is vertical because your vertices are now here. So if it's the bigger number is under the y, the ellipse is taller, the major axis is vertical. C is a value that we get from this equation over here. C is going to be how far we move from the center in order to find the foci. So whatever we get for our center, it's kind of like the p-value that we use to find the focus for parabola. Okay, we moved p from the vertex to get the parabola. We're going to move c in both directions to get the foci for an ellipse. If the ellipse is horizontal, we're going to move left and right. And if the ellipse is vertical, we're going to move up and down. So these are the pieces of an ellipse. So the way that would look then, they're going to fall somewhere on the major axis. So left and right for horizontal, up and down if it's vertical. So let's start by actually graphing these. I think it's easier to draw the graphs first because that helps us get familiar with all the different pieces. So the first thing that I'm going to find is the center, which should be pretty easy. It's the HK that we've been doing. So look at the x, take the opposite sign. Look at the y, take the opposite sign. The direction is based on where the bigger bottom number is. The bigger number here is under the x, so this one is horizontal. That means this is going to be wider than it is tall. Okay, now we're going to figure out how far from the center. So let me go ahead and plot the center. I'm going to figure out how far from that point I'm going to move left and right. So what we kind of have here, these two numbers at the bottom, if you notice in the equation, they were both squared. That's because they both kind of work similar to a radius. Now, it's not really a radius, but it's kind of like a radius. Because if I square root that, I get 5. That's how far I'm going to move left and right from my center to plot my two endpoints. So the square root of 25 is 5. Since it's below the x, that's how far we move left and right. So I'm going to go left 5, and I'm going to go right 5. Those 2 points are the vertices. Now let's figure out how far we're going to move up and down. Well, under the y, we have 9. Square root it, that gives me 3. That's how far I'm going to move up and down from the center to get what are called the co-vertices. So the vertices are on the major axis, okay, the longer one. The co-vertices are on the minor axis, which is the shorter one. So if I want to actually just draw my graph, all I have to do now is connect these dots, and my pencil kind of lagged, and there's my ellipse. All right, so before we find the foci, let me go ahead and fill in the rest of this now that we have our picture. The major axis is the longer one. So the length of that longer axis from endpoint to endpoint, that total distance is 10. The vertices are the 2 points at the end. So -8, 1 and 2, 1. The minor axis is the shorter one. So that shorter length there is 6. The co-vertices are the points that are on the end of that. So those points are at -3, 4 and -3, -2. Domain, we look left to right. The farthest left is -8. The farthest right is 2. It does actually touch those points, so we're going to use brackets. Range, we write bottom to top. The lowest y value is -2. The highest y value is 4. And I use brackets. Now let's talk about C and the foci. So the way we get C, we're going to use that equation that's on your notes. So that equation, it kind of looks like Pythagorean theorem, but it's not. That equation is C squared equals A squared minus B squared. So remember, A squared is one of these two numbers at the bottom. It's whichever one is bigger. B squared is the smaller one. So C squared is 25 minus 9. So C squared is 16, which tells us that C is 4. 4 is how far we're going to move from the center to plot the foci. Since this graph was wider horizontally, we're going to move left and right. So from the center, I'm going to go left 4 and right 4. So my foci would be at -7, 1 and 1, 1. All right, let's try another one. So let's start with the center. Look at your x, look at your y. So my center, opposite sign 4, opposite sign -2. I'm going to plot that first. Now find where your bigger number is. Bigger number is under the y. So this is going to be vertical. It's going to be taller than it is wide. All right, how far left and right? Look underneath the x and square root it. So I'm going to move left and right 5. Okay, how far up and down? Look under the y and square root it. So I'm going to move up 6. And that is my ellipse. Since these numbers are pretty close to each other, it almost looks like a circle, but it is a little bit taller than it is y. All right, let's go ahead and find our C value. So C squared is going to be A squared minus B squared. So C squared is 11. So C is the square root of 11. So that's not going to be very pretty to graph. All right, so what we need to think about, now if you really wanted to graph this, you could estimate, because we know the square root of 11 is somewhere between the square root of 9 and square root of 16. So it's going to be somewhere between 3 and 4. So if we wanted to graph it, we could. But what's more important is we figure out how we would graph it. So since this opens vertically, we would move, or since it's taller vertically, I should say, it's a vertical ellipse, we would move up and down from the center. If we're going to move up and down from this point, we're going to move up and down the square root of 11. What I need to figure out is from my center, am I changing the x or changing the y? Well, if I move up and down, I'm going to change the y. So I'm going to keep the same x coordinate. I'm going to change the y coordinate. The amount I change it by is adding and subtracting my C value. All right, major axis, that's the longer one. So the longer axis there is a length of 12. The minor axis is the shorter one. That's a length of 10. The vertices are at the end of the major axis. So 4, 4, and 4, -8. Co-vertices are on the shorter axis. So -1, -2, and 9, -2. Domain, we go left to right. They will both have closed brackets because they actually touch those points. So -1 until 9. And up and down, we go bottom to top, the lowest to the biggest. The lowest is -8, the highest is 4. All All right, so we're going to do one more, but before we do it, we have to actually write this one in standard form. So in order to write it in standard form, you'll have to notice what's different. All the equations we've looked at in standard form should equal 1. This one equals 36. So what we have to do is divide everything by 36. So if I simplify that, that gives me x squared over 9 plus y squared over 36 equals 1. Now it's in standard form. All right, let's write our center. That's going to be 0, 0, because I'm not adding or subtracting anything. The bigger number is under the y, so it's vertical. Left and right, I'm going to move 3, because I square root the 9. Up and down, I'm going to move 6, because I square root the 36. So from 0, left 3, right 3, up 6, down 6. And that is my ellipse. All right, then let's go ahead and find our c value. C squared is a squared minus b squared. So c squared is equal to 27. And I can actually simplify that square root. It would be 3 root 3. Since this is vertical, we would move up and down to graph our foci. If I'm moving up and down, I'm going to take the center and change the y coordinate. So 0 plus or minus 3 root 3. Major axis is the longer axis, that's 12. Minor is the shorter, that shorter distance there is 9. The vertices are on the major axis, so that's 0, 6, and 0, negative 6. Co-vertices are on the shorter, so that's negative 3, 0, and 3, 0. Domain left to right, negative 3 to 3. Range bottom to top, negative 6 to 6. All right, so what we're going to look at now is we are going to go ahead and write something in standard form. This is going to be the really ugly algebra. Okay, we are completing the square here with x's and y's and a coefficient out in front. So this is going to be a little bit harder than last class. First thing I'm going to do is I'm going to rearrange it. I'm going to put my x's together. So x squared plus 6x plus blank. Then I've got 4y squared minus 8y. And I am going to have a blank, but I need to do something else first. So I'm not going to do that quite yet. And then I'm going to move the 9 to the other side. So before I fill in this first blank, what I want to do with the y's, in order to do that b divided by 2 squared, I have to have no numbers in front of the squared. Right now, I have a 4 out in front. Now I can't just get rid of that 4 because it's part of the equation. So what I'm going to have to do is factor it out. So I'm going to open up some parentheses and divide that from these terms and leave a blank. So now let's figure out what goes in our blanks. Okay, b value divided by 2 squared. That's 9. Add 9 to the left, we add 9 to the right. So that's going to, now let's go ahead and look at the middle set of parentheses. B value divided by 2 squared. But what I add to the right of the equation is actually not going to be 1 because that's not what I'm actually adding here. What I'm actually adding in this case is 4 times 1. So I have to do plus 4 over here. So now let's go ahead and factor it. Okay, these first 3 terms are going to factor into x plus 3 squared. These next two, the 4 is still on the outside. Then the trinomial is going to factor into y minus 1 squared. And then everything on the right can simplify to 4. Well, we're still not quite done. Now we're going to go back to what we did in the last question. It has to equal 1. So let's divide everything by 4. So I've got x plus 3 squared over 4, y minus 1 squared over 1 equals 1. So now if you wanted to graph this, you'd have all the information that you need. All right, so the last thing that we're going to do is we are going to write an equation based off some information. And you'll get a little bit of practice of this when you do the Desmos. What I would recommend is drawing the picture. I think it makes it a lot easier. So we're going to write the equation of ellipse with a center at 1, negative 3. It tells you it has a vertical major axis of 10. So the entire length here is 10. If the entire length is 10, I'm going to go up 5 and down 5. It tells me the minor axis is 8. So if the minor axis is 8, this whole length is 8, which means I'm going to move 4 in both of these directions. And made an extra dot there. So let's write our equation. X minus 1 squared over something plus y plus 3 squared over something equals 1. How far I moved left and right was 4, and I square it in the equation. How far I moved up and down was 5. 5 squared is 25. And that's your equation. All right, so that is it for ellipsis. The process we're going to use next class for hyperbolas is going to start off pretty similar. So you'll see kind of a little bit of similarities next class, but it will be a little bit different.